Greetings, mathematicians. Today we're going to learn some new words. The first is conjecture. And a conjecture in math is a mathematical statement that has not yet been proven true. So today you're going to be making conjectures onto what you think the answer is going to be, and you'll have to prove them true by justifying it. When you justify, you defend your conjecture using evidence. So you're going to have to use some evidence to prove why you think your answer is correct. Okay? So today you are going to make mathematical conjectures and use what you have learned about decimals and fractions to justify them. Our learning target is I can identify and order fraction and decimal values on a number line and justify my conjectures with evidence. Our first question says, which values are represented by the letters A, B, and C? Justify your conjectures with evidence. So I'm going to look at my letters. I see A, B, and C on my number line, but before I can do anything with my number line, I have to figure out what are the numbers on my number line and what does each tick stand for. So I'm going to look at the beginning. I'm starting at 0. I'm ending at 1. So I know my answers are all going to be, all my dots are going to be proper fractions because they're between 0 and 1. Next, I have to count how many jumps I have on my number line. So I'm going to count my jumps. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal partitions or jumps. So that means I know each one is worth how much? Write it down on your paper. I know each piece would be worth 1/10. So from here to here is 1/10. Then I've got 2/10, 3/10, 4/10, 5/10. I'm going to put that in the middle because 5/10. I also know another name for that. 5 is half a 10. All the way up to 1 whole is going to be 10/10. So now I have some reference. I don't want to just start guessing where things go. So I'm going to make my first conjecture. Well, the first thing I want to start with is half, because half is always the easiest for me to find. If I look at my two endpoints, I come meet in the middle. B is going to be equivalent to 1/2. Okay? Kind of have other writing in the way. Next, now I've got 2.2 or 2/10 and 75 hundredths. Well, 2/10, I have my tenths already marked on here. 2/10 is going to be right here. 1/10, 2/10. I'm going to move my 2/10 up there. 75 hundredths. Well, if I look, I've got 5/10 is in the middle. The next would be 6/10, 7/10. This would be 8/10. So if this is 7/10, this is 8/10. In between would be 75 hundredths, or if I think about 75 cents, that would be 3/4 of the way down. If I look at it, I can check. It makes sense. This one would be 2/10, or I could make it 20 cents. This could be 50 cents, 75 cents. I'm definitely getting bigger, bigger, bigger. So that's another way I can prove that my conjecture is true with evidence. I can prove by changing them all to decimals that they indeed get bigger, bigger, bigger. Okay, so my first job is to count my jumps again. I have 10 equal jumps. So if I want to think of it as a fraction, I can think of 1/10 that way, or I could think of 0 and 1/10 that way, like a dime. I'd go all the way across to count them. So if I look at my three options, I've got 3/4 or 3/4, I've got 1/4 or 1/4, and 1/3. Well, if I wanted to, I could change them all into decimals, because that, to me, that's the easiest way to compare them. 3/4 or 3/4 I know is 75 hundredths or 75 cents. 1/4 or 1/4 is smallest. It's only one piece, so it's 25 cents. And 1/3, that's that one that goes 0.3333 repeating forever. By simply changing them to decimals, now I can easily put them in order. My first one is at 1/10, 2/10, in between 2/10 and 3/10, which would be 1/4 or 25 hundredths. That would be A. B is just a little bit bigger than that. So again, if I count 1/10, 1/10, 2/10, 3/10, 4/10, it's in between 3/10 and 4/10, but closer to 3/10. That would be my 1/3, or my 0.33333, like 33 cents. And then my largest one, I know 3/4 is greater than 1/2, and I could also say 5/10, 6/10, 7/10, 8/10. So I know I'm in between 7/10 and 8/10. I would be at 75 hundredths, or 3/4 of the way. Okay, I want you to look at each of the fractions below. What strategy are you going to use to decide which one is A, B, and C? Go ahead and figure out your strategy, pause, and then check to see if you're right. Well, I like to always change everything into decimals when I have them all in the same form, either all fractions or all decimals. It's easiest to compare. Since these are ones I have memorized, to me it's easier to make them decimals because it's easiest to compare decimals. I don't have to make common denominators. I want to make less work for myself. Okay, so now 1/3 is like my 33 cents, 8/10. Remember, I could think of that as 80 cents. And 2/3 is 66 cents. So if I want to put them in order, well, my 1/3 is going to come first. Again, that's in between 3/10 and 4/10. Next, I'm going to have my 66 cents, or my 2/3. If I look at that, I can see I've got 1/3, 2/3, 3/3. So I can see my thirds actually by breaking it into 3 equal pieces. And my largest one, which I could prove by writing that I've got my 5/10, 6/10, 7/10, 8/10. That's right at a tick, which is 8/10, would go there. So again, by converting to decimals first, it's a lot easier to compare because again, then they're all in decimal form. I want them in the same form or have the same denominator so they're easy to compare. Okay, let's look at this one. Look at letter A, B, and C. Now I have to look. I have something that changed this time. Now instead of going from 0 to 1, I have 0 there, 1 there, and 2 there. So now I have to think, when I break into a fraction, I have to think how many pieces do I divide one whole into. So I'm just going to count my first one. I'm going to count 1, 2 marks, so I know each one is 1 part out of 2. So I've got 0, 1/2, 1 whole. Now I'm at 1, so I have 1 whole and another half, 1 1/2, and 2. If I want, I can change these to decimals. I know what 1/2 is as a decimal, 5/10. I memorized that one. I know what 1 1/2 would be. 1 and half is the same as before, 1.5, 1 1/2. So now I have decimal values going across. If I wanted to put my zeros after here so I could think of it that way, I could as well. So let's look at my choices. I've got 4/3, 1 75/100, and 1/4. Well, if I look at it right away, only one of these values is less than 1 whole. This one is an improper fraction, so it's more than 1. This one is more than 1 because it has a 1. And this one is less. I also know that this is the same as 25/100. So my smallest value, my only proper fraction that I have on here, is going to be 1/4. Now I have 2 options left, 4/3 and 1 75/100. Well, I could change this to a mixed number, and maybe that would help, or I could change it to a decimal. Well, 4/3, I know 3/3 is 1 whole, and then I have 1/3 left. Now I want to change that into a decimal. I know it's 1. 1/3 is 0.33 repeating. So now I've got $1.33 if I think of it like money, and $1.75. Which one is going to be at letter B? Well, my 4/3, because $1.33, or 1 1/3, is going to be less than 1 1/2. And now $1.75, or 1 3/4, is going to be greater than 1 1/2. Okay, same thing here. Look at your choices. This time I see if I look at my number line, I want to always start with my number line. I've got a 0 and a 1. Got the same idea as last time. I've got 2 jumps, or 2 partitions, so each one's going to be 1/2. Let's have 2 more partitions over here, so now I'm going to be at 1 1/2. That gives me some reference. Now look at my choices. Well, I've got 2 that are already in decimal form. If they have the same number of places, then I can compare them easier. So this first one's like 10 cents. This one's like 1 cent. Well, which one is going to be smaller? I can already rule this one out as the smallest. That's going to be greater than 1 because it's an improper fraction. So which one of these is going to be smallest? Well, 1/100th is going to be my letter A because it's like 1 penny. If I divided this into 100 little pieces between 0 and 1, it'd be that first little jump. Then 1/10. That would be like my 1 dime. That's if I divided this into 10 equal jumps. Now, I don't even have to solve the next part if I don't want to. I don't have to do the math because I know there's only one letter left. This one's 5/4, but if I wanted to change it into a mixed number, I could say it's 1 whole, because 4 goes into 5 once, that's 1 whole, and then 1/4 left, or 1.25. 5 if I wanted to change it into a decimal. Okay, go ahead and try this one on your own. Pause, put your values in, and then check to see your work. Again, look at what your benchmarks are that you can see. I'm going to look at 0 and 1 again. It's my same number line that I've been using. 1, 2 jumps, so each one is 1/2 or 5/10. 1, 1.5, or I could think of it as 1 and 1/2, 2. Okay, so now let's look at my choices. 21/10. Whoa, 21 is bigger than 10, so I know that this is an improper fraction. I don't like improper fractions because it's hard for me to picture, so I want to make it into a mixed number. How many times does 10 go into 21? Well, 10, 20 goes in 2 whole times, and I've got 1/10 left over. Or if I want to write it as a decimal, because I like decimals when I'm comparing, 2 and 1/10, I could put the 0 there if I wanted to think of it like money, $2.10. The next one I've got 40 cents, already in a decimal form. And then I've got 4/3, another improper fraction. So I'm going to change that to a mixed number because it's easier to deal with. How many times does 3 go into 4? 3, 1 time. And then I've got 1/3 left over. If I want to change that into a decimal, 1/3 is 0.33 repeating. So now I've got $2.10, or 2 and 10 hundredths, 40 hundredths, and 1 and 33 repeating. So let's look. Which one would our smallest value be? Well, our smallest value is going to be our 40 cents, or our 4/10. That makes sense because right next to it is going to be our 5/10. It's a little smaller than 5/10. Now I'm going to go to B. B is in between 1 and what I've marked as 1 and 1.5. Well, would that be 1 and 33 hundredths, or would it be 1 or 2 and 10 hundredths? Well, I'm not at 2 yet, so I have to be at my 4/3. I'm at 1 and 1/3. It's a little smaller than 1.5. Now, 2 and 1/10, or 21/10, is bigger than 2 wholes. So that's the only one that makes sense to be larger than 2. Okay, so now we're going to practice a I bet word problem. So what's going to happen is I'm going to read one line at a time, and then you're going to make a conjecture of what you think is going to happen next. Angela read 3/4 of her book last weekend. Cammie finished 2/3 of her book. Logan read 7/10 of his book. What question do you think I can ask about this? The question I'm going to ask is, who read the most, and how do you know? Well, I know Angela read 3/4, so I'm going to write down Angela. I'm going to write down 3/4. I like to think of it as a decimal. It's easier to compare decimals, so I'm going to think of 0.75. So that's Angela. Next, Cammie, she read 2/3 of her book. So 2/3, the decimal form, is 1/3 is 333, 2/3 is 0.666. So now I know Cammie's value. And Logan read 7/10, so I'm going to put L for Logan. He read 7/10. I know I write that 0 and 7/10. If I want them all to have the same number of spots, I'm going to put a 0 in the hundreds place. So now we've got Angela who read 75 hundredths, Cammie who read 0.666, or about 66 hundredths, a little more, and Logan who read 70 hundredths. So can I compare them? My question was, who read the most? Which answer would be the most? Our answer would be Angela read the most. How do we know? Because 75 hundredths is greater than 70 hundredths and 0.66666 repeating. So our learning target was, I can identify and order fraction and decimal values on a number line and justify my conjectures with evidence. Give yourself a rating. If you're an at-home learner, look at your Google Classroom for what your next assignment is. If you're an in-class learner, your teacher will show you.